Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture we'll discuss the problem related to meta-centric height and its stability. So in our previous lecture already we have discussed the theory part and the problem related to meta-centric height, but here I am going to tell you that whether the body is in stable condition or not. Okay, and previously also we have already discussed regarding the buoyancy and the force of buoyancy, and also we have discussed the center of buoyancy and the gravity, center of gravity point, then also meta-centric height, meta-center and meta-centric height. These are the points we already have discussed in our previous video lectures. So related to that we will solve one problem and we will find out the meta-centric height, and we will also define whether the body is in stable or unstable condition. So here I have taken an example of a solid cylinder of diameter 4 meter has a height of 3 meter. Find the meta-centric height of the cylinder when it is floating in water with axis is vertical. Specific gravity of the cylinder is 0.6. State whether the equilibrium is stable or unstable. So first let me consider a solid cylinder. So let me draw a solid cylinder like this, in which the top will be a circle part and bottom also will be a circle one, and just you can draw like this. Okay, now the diameter of this cylinder is given, this is 4 meter. So this one we can mark it as a 4 meter, and height of the cylinder is given, that is 3 meter. This is given 3 meter. Okay, and now the axis of this object is, if you draw this axis line of this body, okay, so that is floating in this object is floating in the water with the axis is vertical. So now exactly in this position only the body is floating on the water. So if this is the position of this body, then we can find out the front view of this, will get a rectangle, and top view will be a circle one. So we don't need to draw the top view, front view is enough for us because it is going to be sink, so suppose like this water layer is there. Now the body is floating on this means only we need to draw the front view of that, which is like a rectangle type will be there. Okay, yeah, we can draw a rectangle, and then we draw just the axis line of this. And now here we need to find out this total height is given here. The total height of this object is given, as I told you already, it's given 3 meter. Okay, and this is 4 meter, and diameter of this is 4 meter. Now here we can mark one point which is defining the center of gravity of this object. Okay, so this is one thing. Now next point is we need to also mark the point which is the B point, which defines the center of buoyancy of the object. Now the data given for what? The specific gravity of the cylinder given. Specific gravity of the cylinder is given 0.6. Okay, and diameter given and height is given. The remaining nothing is given. Now we need to find out the meta-centric height. So we know that the meta-centric height formula is nothing but GM equal to I by V minus BG. Okay, this is the formula for the meta-centric height. Correct. So now give me a point of A here at this bottom of this A point. Now I is the moment of inertia, V is the volume, and BG is the distance from the center of buoyancy to the center of gravity point. Okay, so for this I'll just start the point, like what is the depth of immersion of this body inside this fluid level. So this is actually water level is there. I have not marked here, but it is already in the water and floating of this level. So now this immersion of this height in this fluid, this one you can consider the H. Okay, now how much portion is inside the water level? So that also you can calculate. So this one already I have mentioned there, 4 because the diameter of the cylinder is 4. So we can draw like this. Okay. So next thing what I'll do, the depth of immersion of the cylinder, I'll just find out. Okay, how much is inside the cylinder is there. That we need to mark it here. Okay. So that is actually how we can find out. So let's find out. So the depth of immersion, we can write the depth of immersion of the cylinder equal to the specific gravity of the body, that is 0.6 into the height of that object. Based on that it was immersed inside, so we can write this one. So that is nothing but 1.8 meter. Okay, 1.8 meter. So I can also identify how much portion is H value. Also we can identify in this way, like what is the specific gravity of this body and total height of that body how much. So based on that it is inside this fluid level. So the depth of immersion is nothing but 0.6 into 3, we can write 1.8. Now this is the 1.8 is the nothing but the height is there. Now the next thing what we'll do, we can find out the value of AB, the distance of AB. Okay, so AB we can find out, that is nothing but we can just the total of this 1.8 divided by 2, so that will be nothing but 0.9 meter. Okay, and similarly AG point, already we know the height of this, so AG also you can write. AG is nothing but the half of this center of gravity point, so that means the total height how much is there divided by 2, so that is nothing but 1.5 meter. Now it is very easy to find out the BG point, so we can write BG equal to we can write AB minus AG, A to G point, sorry, AG minus AB. So AG already we got here 1.5 minus 0.9, so that will be 0.6 meter. Okay, this is BG point we got. Correct. Now as I told you, I is the moment of inertia of the body. So moment of inertia for the cylindrical case. Okay, for the cylinder, if you see the top view, it will be like a circle will be there. Correct. So this will be the axis line for this. Now this is YY point, and the moment of inertia about the YY axis of this, we can write what is the formula for this. Now pi d4 by 64. Pi d4 by 64 we can write the formula for this. And volume, this is D is given already, so we can identify this one. Now volume is the next one, volume of the cylinder inside the water, this much volume which is inside the water level. So that also we can write. This is volume of the cylinder, we can write the area into depth of immersion directly. So area is nothing but pi d square by, we can write pi d square by 4 into the depth of immersion is nothing but h. Okay, so that is also you can write pi d square, that is nothing but 4 square into divided by 4 into h. How much we got? Now 1.8 we got. Correct. Now this is volume. So finally what we'll do, I'll write this formula of meta-centric height, GM equal to I we got what? Now pi into 4 to the power 4 by 64 divided by V. Volume we got here, this one, pi into 4 to the power square divided by 4 into this is not 1.8 and minus which one? BG is nothing but 0.6. So here if you see pi will be cancelled, okay, and 4 square, 4 to the power 4, here 4 to the power square will be gone, then how much? 4 to the power square will be there, correct. So 16 divided by this 64 is there, so that will be 4. So like this, if you see, most of the things will be this 4, again this 4 is going to cancel. So finally what will be there here? Now finally we'll get here GM equal to 1 by this, all these things is going to cancel, 1 by this 1.8 is there, 1 point is not going to cancel, and minus 0.6. So this will be give you the value 1 by 1.8 means it will be near about, you know, some point value will be there. Let's see how much is there. We'll calculate it. Exact value will get it there. 1 divided by 1.8, 0.5555 will get. Okay, then 0.555 something will get, minus 0.6. So it will be give you the value of minus 0.05 meter. So here the GM value, the metacentric height, we are getting negative value. This negative value actually indicates that the body is in unstable condition. So we can write the body is unstable condition because the center of that metacentric height we got here is a negative value. Okay. So this is the procedure to solve the problem related to the metacentric height and how to identify its stability. So that also we can clear from this. So this kind of questions may be given in the, you know, in your exam you can get it this kind of question, or else you will get this kind of questions in the competitive exams. So if you know the formula, then you can solve easily. So basically what are the main formula required here? If you see, one is the center, the metacentric height formula, one is the moment of inertia, and next one is the volume of this cylinder. Okay, these three things are main things on this, and also we need to know the concept of this, you know, like how to find out the center of buoyancy point and the center of gravity point. So I hope you clear in this. If you are having any doubt regarding this, you can give a comment on the comment box. Thank you all.